Good day. Our first unit that we're going to attack is all about energy. And so we're going to talk about classes and forms of energy. And then we will go from there. Alrighty, so let's rattle through this early stuff. Energy is defined as the ability to do work. And there's a physics definition of work. So what does that mean? It means we have to apply a force and we have to move an object a distance. So first of all, work is energy. Work occurs when a force applied moves that object a distance. So we have the work formula. Work equals force times distance. So let's go through what these things mean. Work, measured in joules. Since it's named for a dead person, gets a capital J for its units. Force is measured in newtons, named after Isaac Newton, capital N. And distance must be in meters. Before we go to the forms of energy, we look at two classes of energy. So we have potential and kinetic. Potential energy is simply stored energy. It's waiting to be used. If someone has an elastic band and they pull back on it and they aim it at you, you're not worried about it moving at that time. You're worried about the fact that it could move, that it has elastic energy, potential energy, which can be converted into kinetic energy that can then have the elastic hit you. Kinetic energy really is the energy of motion. So moving things are going to have kinetic energy. And forms of energy and class of energy are changing all the time. Now, depending on what books you look at, there are all kinds of different forms of energy. And the way we're going to go through it, some will fit into both the category of kinetic and potential energy. But you do have to make sure you know the difference between classes of energy and forms. So here are examples of kinetic energy. Heat is kinetic energy. So we are looking, often called thermal energy. This is due to the fact that the particles of an object or material are moving. The faster they're moving, the more heat they have. So if you can see things, that's related to light energy. Hearing things, that's sound energy, vibrations. Now we look at potential energy, gravitational. So a boulder on a cliff is going to have gravitational energy from its position. It may just be sitting there, but we know it could fall. And that gravitational could be converted to mechanical energy. Magnetic energy related to magnetic fields, and they're simply magnetic materials that are attracted and repelled in certain situations. We'll get to that later in this course. Chemical energy, the energy stored in the material and its chemical bonds. You eat food. One of the reasons you eat food is you can take that chemical energy and convert it to useful forms of energy in your body. If you power a car with gasoline, that chemical energy in gasoline is unleashed and your car can move. Nuclear energy, so the energy stored in the nucleus of an atom, that's where that comes from. And elastic is stored, so we can stretch things, we can compress them. So if you take a soccer ball and compress it against a wall, it'll spring back. That's elastic energy. And we're looking at some that fit both categories. Last year, you would have learned about electrical energy. And so you might have learned about static electricity. Static means stationary, so you're building up non-moving charge. And that's where if you rub a balloon on hair, and then you can stick the balloon against a wall, or the buildup of charge for lightning. Current electricity is the flow of electrons through a conductor. Now mechanical can have a number of meanings. Some books will have mechanical meaning the total energy of a system. But often we'll think of it as simply the energy possessed by an object that's moving. So if you have an airplane flying, a baseball's been thrown, those kind of things would have mechanical energy. Vital energy can be a hodgepodge of many forms, but very simply we say living things have vital energy. So that living thing could be a cedar tree, it could be you, it could be your pet hamster, as long as the hamster's alive. And solar energy is the energy stored in and produced by the sun. So we think about things like heat, light, although it does make different forms of radiation. So let's look at some examples, and there are going to be so many, so we've just narrowed it down a bit here. So heat, we think of anything that's warm. In fact, anything above absolute zero, minus 273 degrees Celsius, has some heat energy. So those things all have heat. Anything that produces light, light energy. Anything that makes a noise, sound energy. Gravitational, many examples. Magnet, well, of course you have magnets themselves, and the Earth is a giant magnet. Chemical energy, all kinds of chemical energies out there. And nuclear. So in that case, we're using nuclear power to make electricity. Hopefully you're not making nuclear bombs in your backyard. And then we have elastic energy, anything that's been deformed and stretched and wants to move back to its original shape. Electrical, we're looking at devices that use electricity in this case. And mechanical, a car engine. And vital, any living thing. And there's solar, so the sun and any kind of star. Now, if I run out of words there, that would be exciting. And it says I have. So those are your intro notes. If I went too fast, just pause things and make sure you got that all copied out.